Okay, trying to sketch the graph of y equals sine x over x. So we'll just draw this. Okay, so first things first, just try to find out in this. Okay, yeah. Oh no, that doesn't apply. Never mind. Okay, so for the I was thinking because it's sine x, it should go between 1 and -1, but obviously because it's being divided by x, that might make it a little different, so pause on that. Anyway, so we'll start with the intercepts. Obviously there is no y-intercept, because if there was a y-intercept then x would have to be 0, but x cannot be 0 in this case because you can't divide by 0 because x is at the bottom, so there is no y-intercept. And then for the x-intercept, it will be when y equals 0. So basically, since x is not 0, sine x would equal 0. And arcsine, that will be 0, pi, 2 pi, 3 pi, and so on. Right. So we have that. So we know there is an intersection over here. So basically almost like a sine graph in that sense. What about negatives? Let me think about negatives as well in this case, because yeah, so that will give me negative solutions as well, because sine minus pi would give me 0, and then minus 2 pi. Yeah, so yes, so that also works for negatives, right? But wait, we say there's no y-intercept, so x can be 0 here. Sorry, x can be 0, so there is no so the solution x equals 0 doesn't work in this case. Let me just write that there. X is not equal to 0, right? But then, okay, we'll leave it like that. Then what else? Okay, we can try to find any turning points. Since y equals sine x over x, and the derivative would be, let's say, x squared over a, then x cos x minus sine x. So for turning points, that would have to equal 0, so that's x cos x minus sine x equals 0. Now yeah, that makes the situation a bit difficult now, because if it was only cos x and sine x, that would have been better, but that's clearly now a problem in this case, because even if I divide by cos x wrong, then I'll have sine x left on the other side. I could try. So the graph, yeah, it becomes a problem. So I don't think this helps much, because in terms I don't remember something that then x y equals x would be like this. So that's clearly too many intercepts. So yeah, I sort of jammed over here. Okay, you know what? We can try thinking about what happens as x gets bigger and bigger. So I know for the top function, it's going to oscillate between -1 and 1 for these top parts. And then if x is getting bigger and bigger, which means the bottom part will be getting bigger and bigger, which means that yeah, you'd be tending towards 0. Yeah, and yeah, you'd be tending towards 0, and then you'd be alternating between like positive, negative, positive, negative, positive, negative. Right. So we know it's tending towards 0. So it's, but is it tending towards 0 from, yeah, that is an interesting question. When is, yeah, wait for sine graph. That's 0, pi, 2 pi. That's about 3.14, and that's about 6. So from 0 to pi is definitely positive. Yes. So is definitely positive from like 0 to pi. So I think it's definitely like this, for sure. And then between pi and 2 pi it gets negative. So I know as x gets bigger and bigger, it's getting closer to 0. So I know this side is probably, hopefully, yeah, because I'm probably lying. But this is what I have for now. And then it gets smaller, 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 smaller. Yeah, as we go like that. And then for the negative parts, because let's say we have let's try minus pi over 2. Since this minus pi over 2 will be somewhere here, sine minus pi over 2, that's, I'm pretty sure that's -1. Yeah, -1. So I know, yeah. Okay, so between, okay, you know what? I have the graph over here, so I can just, yeah, I can just refer to that. So that's 0 minus pi. Yeah, it's definitely negative. So it will be something like this, and then getting smaller and smaller and smaller as well. So it will be just the same as this part, but obviously coming from the negative infinity. So that's what I got. So let me check.
Okay, because x approaches.
Yeah, I was not doing that. I cannot lie, bro. Oh, yeah, I did not have. Yeah, that is wrong. I got it wrong. Lopez was wrong. I should have. Yeah, I got that wrong. I got that terribly wrong. Okay, I had the right idea. I can say that I had. Yeah, it was just that. Yeah, nah, never mind, bro. Chacho. Got it wrong. So yeah, I got it wrong. But I'll have to listen to how he explains it, especially the L'Hopital's rule part. But anyway, thank you.
I'm back.
Oh yeah, okay. Back to it. I just realized that I hadn't taken this into account. But if I had minus pi, for example, I'd be dividing it by minus pi, so that will give me I would have drawn it like this for sure, and that is wrong. But yeah, why would the maximum be 1? I don't get that part, but yeah. Oh yeah, and then yeah, I was watching through the video, and then it was in front of me actually, because this L'Hopital's rule, if you substitute 0, that's sine 0 is a 0, the next 0, so it's 0 over 0. So you have to use L'Hopital's rule, and then differentiate sine x and x. Okay, that part makes sense. We're moving. Oh yeah, and then it just hit me again that if the top part sine x is in the range -1 and 1, and then you're dividing by x, which will be like an equal number or greater than, you know, the stuff, or greater than -1 to 1, which means that you're always going to get values of y which are not greater than 1. I'm not sure about between -1, but it makes sense why it's up to 1 and not beyond. So I got that part. But when I try to plot it, I'm not sure how that works though. Is it that you just draw a graph and then it just ends like just before it reaches the y-axis? Because when you like plot the graph and you try to look for the y-intercept, because surely there is no y-intercept, and the calculation gives me an error. So I'm not sure how that's happening. So yeah, but yeah, okay.